So today at like 4 in the morning for me, the new version of Bevy came out, and apparently broke YouTube's analytics, which is kind of fun. Yeah, so it like actually broke YouTube's analytics. That, or somehow everyone knew that the new version of Bevy was coming out exactly 24 hours before it did, because we go to my YouTube analytics. That's 24 hours. Like at exactly 3 to 4, 24 hours ago, exactly 24 hours before Bevy came out, a whole bunch of my videos got a whole bunch of views. And I don't know if that's YouTube breaking or something happened automatically 24 hours before Bevy released that told everyone that Bevy was about to be released, because it's just on 24 hours before it came out, and then came out here. So as you notice, there's no actual uptick with Bevy coming out. So it's not like YouTube started pushing my videos or anything. And then this is me releasing a video that is doing quite well at the moment. Let's jump into it. So today, Bevy 16's come out. They've added GPU-driven rendering, procedural atmospheric scattering, decals, which I want to do a video on because they look really cool. Occlusion Culling, ECS relationships. So they've removed parent-child and replaced it with like a built-in relationship structure, which means that you can actually build your own custom relationships rather than having to reinvent the wheel. You can use the optimizations. And they also relate to, I don't think it's mentioned here, immutable components, which I wish I'd known about when I made my observer video, because they're actually relevant to how you can make observers more sound, because you can say that a component can't be modified once it's been added. Improved spawn API, which they say improved. I think it confuses me, but that might just be because I haven't actually used it and their examples are not entirely clear of how it's actually working. Unified error handling, which is going to be amazing for like a lot of people that say that Bevy's like hard and Like the fact that they've unified it into a singular thing means that it's much easier to use the question mark operator to return traits up and then have Bevy just log an error. Like it gives you the flexibility to crash during development, but only log it during deployment. So like it makes the code much better. No STD, which I am super excited for. I don't know if I have the skills for it, but I would love to get Bevy running on a Raspberry Pico. So fast transform propagations, they're saying that they basically optimized it so one, transforms aren't propagated if none of the transform changed, or if something does change, only the children of something that got changed will be updated, but the parents won't. And they reckon that it's like 11 times faster. Percentage increase isn't important. Like the fact it's 11 times faster isn't important. It's the fact that it's 6% of your frame budget was being consumed by transform propagation on that particular scene that they were using, and it's now 0.5% of your frame budget instead of 6%, which is incredible. GPU-driven rendering. The idea of GPU-driven rendering is instead of the CPU deciding what needs to be rendered when, you load all the data onto the GPU, and then you send the GPU like updated transforms, and then a list of things that can be seen, and the GPU is in charge of working out what's like occluded, like if it's behind something else, what mesh to render, like all that, like that is handled by the GPU, which means that the CPU can be doing other stuff and it's just significantly faster. And then the GPU also does it in one draw call and has all the meshes loaded in such a way. For each object, the CPU will send the transform. GPU-driven rendering is like a bunch of techniques rather than a singular thing, like unified thing. Multi-draw indirect, which I believe is when they talk about you issue a single draw call rather than individually sending each mesh. You send an array of meshes and then you point to which mesh you want indirectly, hence they're multiple indirect. And then the bindless resources, which allows Bevy to supply texture for many objects as a group. So I think that this is like the same thing again, but with textures instead of meshes. So they bundle all the meshes into like an array of all the clip meshes directly together, and then each texture can grab its specific thing by indexing into that array rather than using the built-in GPUs like texture sampling, because that requires binding the texture and all this other stuff that has limitations. So GPU transform and culling means that basically Bevy provides the position and visibility of every object, but the actual GPU can then, like when it applies that to the mesh, and therefore has a much better understanding of what's actually being blocked by other things in the scene, can then block things. Retained render world is they're saying that instead of updating the data every frame, if it hasn't changed, it just gets to stay on the CPU. And cache pipeline specialization, which leverages the component level change detection to more quickly determine whether a rendering state of a mesh is actually unchanged, and therefore can optimize not sending it back and forth. Unless you're directly interfacing with shaders in your code, it's a drop-in replacement. Bevy will handle all this behind the scenes, and it'll just be faster. Like there's nothing you have to worry about. It's only supported for 3D pipelines at the moment, but apparently all the techniques, they work really well on 2D. So maybe 17 will mean that 2D rendering is like even faster again. Up next, procedural atmospheric scattering. So in 0.16, Bevy has now got the ability to simulate day-night cycles. So let's start this video from the beginning. So the idea being that they treat every directional light as a sun, and therefore it will actually simulate like a nighttime haze sort of thing of the sunset, sunrise as the sun goes above and below the horizon. And they're saying that to do the skybox here that you see, what they're doing is they're just adding a skybox that is the stars, and as the sun comes up, it blends to the simulated atmosphere, which makes the sky disappear, like the stars disappear. So you don't actually have to do anything special to try and make stars disappear during the day. Just having a skybox that is what your nighttime will look like, and then the daytime will actually cause scattering to blot out the stars, which is what actually happens in real life. Next up, decals. Decals are textures that can be displayed or laid on top of a mesh, rather than changing the actual mesh texture. The advantage is being that you can dynamically represent player actions like bullet holes in FPSs, apparently, or like graffiti is the other thing. Like when you spray your tags on the walls, like that's using a decal, so it like projects it onto the wall. And it means that they don't have to dynamically update all the textures. They can just add a decal. Experimental occlusion culling. So occlusion culling is the idea that we don't have to render something if it's behind another object. For example, we don't need to draw a person who's hiding behind a wall, even if they're actually within the range that the camera would in fact render them. An important note is that occlusion culling won't be faster on all scenes. Small scenes won't benefit from the culling as much as larger scenes. They spend more time trying to cull things than they save from things that they end up culling. So the more stuff in your scene, the more likely something will actually get culled and therefore be worth checking to see if it should be culled. Make sure that you actually check yourself whether your performance is improved. Anamorphic Bloom. So this is the idea that in old-timey cameras, they would take a wide picture like this and then project it onto film, which was square or like not as wide as the size of the camera. So if you ever go to a movie theater and you see a movie in 2.34, which is the like aspect ratio is really wide versus the 9:16, they actually used to, when they made film, compress the 234 onto 9:16 film. And so that would squish the bloom, because obviously the camera had an equal amount of bloom in every direction, but you've now squished this, so that equal amount of bloom, when unsquished, makes the bloom wider in one axis than another. And Bevy is now saying that they allow you to specifically set bloom to be like different in each axis, and therefore can have the this bloom effect. Okay, now on to ECS relationships, one of the exciting things. When building Bevy apps, it's often useful to link entities together. Most commonly, this is the hierarchy with the parent-child relationship stored in a list of children for one entity and in a parent component on the other, which points in each direction. It's really easy to create your own custom relationship with a macro tag, the specific entity that is the relationship that you're talking about. And same here, where you can say that like you specify the actual list that is the target. The way that Bevy handles this is that the relationship component is the source of truth, which means that if the relationship is modified, then the relationship target is updated accordingly, but the relationship target can't be updated. The idea of this is that you can get rid of a lot of the expensive checks for deduping and stuff, because you know that the relationships can only be changed in one direction. And that ties into the new Immutable Components feature, which basically says that you can't modify these components once they've been inserted. The only way to change the data is to insert a new copy with the new data. This means that the onAdd and onReplace hooks get called accordingly, and the data is maintained correctly. Improved spawning API. Bevy's currently working on the editor, and part of the editor is the next-gen scenes and UI, which is by like making everything more user-friendly before they release an editor using it. So you can spawn and give a component. You can spawn an iterator, provide an iterator of components. You can spawn with, and then say when the parent, and then you have the child spawner, which then allows you to dynamically write some kind of function that determines what children to actually spawn. And they're saying that this also works with any relationships. Another big change is the unified ECS error handling. As of 0.16, Bevy has said this is how errors will be handled, which is using the global error handler. And the idea being that Bevy exports a result type. So systems, observers, and commands now support the result type. So the idea being that you can pop over to here. So it's a system, and I can say, hey, the system returns result. Like so, and that means that it can return a Bevy result. So like a Bevy error, and then a Bevy error is apparently like any error type can be a Bevy error. The idea being, because it's so universal, the errors can propagate really easily using the question mark operator. They have better backtracing apparently than anyhow, because I think
the big difference is that Bevy knows what's like noise from Rust and what's noise from Bevy, and will strip that out, whereas Anyhow won't know that because it doesn't know about Bevy, so it can't strip out Bevy's noise. It'll just have all that in its backtracing. So you can override the global error handler, and so like they're saying here, you have it panic during development, and then you can have it log silently in the background when it's a deployment, which greatly improves the experience for people using your application, since they don't have to worry about like the game crashing because you forgot to deal with somewhere where you were unwrapping. So Bevy no STD support, which is something that, again, I mentioned at the beginning of the video, I am really excited for, because hopefully Pico Bevy. But in this example, Chris here made a Game Boy Advance run Bevy, apparently. So that's really fucking cool. There's an unusual platforms channel on the Discord that you can go see what platforms Bevy supports now that it's got no STD, which is fun. Fast transform propagation. So transforms in Bevy come in two flavors, global and local. So the global one being the actual world space scale rotation of an object, whereas the normal transform is the relative to the parent, and so hence the local. In order to compute the global, you need to iterate through all of the locals down to that point. They're testing the huge Call of Duty Warzone map. Shows that it takes about 1.1 milliseconds to do all the transform propagation on Bevy 0.15, and then it takes 0.1 milliseconds on the 0.16. So that, like, it's a huge 11 times performance increase. But again, as I mentioned at the beginning of the stream, the big difference isn't necessarily that it's 11 times faster, but instead that you only have 16 milliseconds to do a frame at 60 FPS, and 6% of that was consumed by doing hierarchy calculations. And that's just insane. But with, an 11 times performance, it's now down to like 0.5% of your frame budget is now used calculating. You can see the huge difference. So Specular Tint map, which basically is that the light that shines off of a shiny reflective surface called the specular highlight. So we see the sun shining off it, can now be tinted. And they're saying that this is behind a feature flag because it's expensive to sample textures like this, and you have to provide a texture that tells it like what color the specular highlight should be at a specific point on a mesh. Experimental WESL shaders. So the idea is that Bevy's been using WGSL for a long time, and they've built their own extension onto that. Basically what they're saying is that a new experimental like beyond Bevy things coming out, which is WESL, which does all these extensions onto WGSL, that Bevy's basically doing. So it's also backwards compatible in that like anything that's valid WGSL is also valid ESL, which allows for you to basically port your code over unless you were using some of the Bevy specific extensions, at which point like they have a link to how you can change like the migration guide for changing your shaders over. Immutable components, which in 0.16 they added immutable components, which is data that cannot be mutated once it's inserted, so you can't query for a mutable reference to it. It will not compile, which is a great way of doing this because it really leans into that Rust will not compile if you're doing something wrong. And so Bevy is specifically one, this is wrong, do not compile. Entity cloning. Bevy now has a first-class support for cloning entities, which it was possible to do using Reflect. Now, all you need to do is derive the normal clone trait, and this will automatically enable Bevy to be able to clone, skipping those that cannot be cloned. Entity disabling and default query filters. So 0% added the disable entity by adding a disabled component. This by default will hide the entity and all of its components from systems queries that are looking for it. Okay, so the idea being that if you put the disabled component onto an entity, a query looking for the entity will not find it. Better location tracking. This one is kind of cool. Bevy's unified data model allows introspection and debugging tools to be written for the entire engine. Last release's track change detection feature flag lets you automatically track when a line of source code inserts or mutates any component or resource. Now it also tracks with code, triggering a hook or observer, sent an event, okay, so an event caller, okay, spawn or despawn an entity. And as a side effect, this leads to a nicer error handling message in some cases, such as these nicely implemented despawn messages. Entity was despawned by having outgrown its name. The feature flag is now track location. And the way that they do this is really cool. There's a maybe location. So a lot of things return a maybe location, which it's similar to an option that returns some if the feature is enabled and none if the feature is not enabled. But it's set at compile time, which means that you will get like the functions that you call on this will get completely optimized away by the compiler because they do nothing when the feature isn't set, but they do something when the feature's set. So you can have debugging code that runs because it won't be displayed unless you actually got the feature enabled, which allows for like really good error handling. Gets cleaned up entirely for release builds because they don't need to actually contain that data. Okay, so text shadows. Okay, Bevy UI now supports text shadows. That was straightforward and easy. Just add text shadows. Input focus improvements. So the idea of this is that it has a specific resource called input focus, and that's what the user is currently focusing on. And then by using navigation, in this case, it's saying tab navigation, which will just like when you press tab, it'll go to the next thing in the list, and also a hybrid search algorithm or explicit navigation links, meaning that I'm assuming will be like, this is the size of the box, and then it scans to the left if you press left until it finds something that would be intersecting that box and be like, that's probably the next thing that you want to select because you pressed left from here. And explicit navigation links being that if they press like a specific direction, go to this entity. So the idea being that like they've got like a way of creating non-mouse focused navigation to a UI, which is amazing. Retained gizmos. Okay, in previous versions of Bevy, gizmos were always rendered in an immediate mode style. They were rendered for a single frame before disappearing. With retained gizmos, you can now spawn gizmos that persist. Transparent sprite picking. Okay, so in most cases when working on a game, you don't want to click over the transparent part of a sprite. In previous versions of Bevy, sprite interactions were handled on a simple bounding box click. If your cursor was within the bounds of the box, it counted as a click. In Bevy 16, when interacting with the transparent section of an entity sprite, those interactions will pass through the entity to the entity beneath it. No changes required to your codebase. Okay. By default, pass-through will occur for any part of the sprite which has an alpha value of 0.1 or lower. Okay, AssetChanged query filter. In Bevy, assets are data we hold a single copy of, even when used by multiple entities. Things like sounds, images, and 3D models. Assets like images are stored in the assets images resource. Entities that have components like sprites will hold a handle to an image, which identifies which asset they use. While this works great for storing tens of thousands of ogre meshes in memory while you're making a tower defense, this relatively indirect pattern makes it hard to figure out when an asset that you're relying on has changed. That's because the handle could change, pointing to a new asset, or the underlying asset could change, modifying the underlying data. Okay, while querying for changes sprite, will catch changes to the handle, it won't catch changes to the underlying asset. Mesh tags. I'm not sure what this exactly does. I think it's just saying that shader, you can now use a mesh tag to tag something that can then be accessed in the shaders. It's trait tags on Rust docs. Okay. Bevy provides several core traits that define how a type is used. For example, to attach data to an entity, it must implement component. When reading the Rust API docs, depending whether a type is a component or some other core Bevy trait, requires scrolling through all the docs until you find the relevant trait. But in 0.16 on docs.rs, Bevy now displays labeled indicators with which core Bevy traits a type implements. That's kind of cool. This happens for the traits plugin group, component, resource, asset, event, schedule, label, system set, system parameter, relationship, and relationship target. Okay. All right. What's next? So Bevy is going to revamp the Observer API because, of course, they do. I make a video, they change it. But it does actually sound pretty cool because they're planning on using it for one-off UI. The other thing that they're going to do, which I'm not 100% sold on, is resources as entities. So the idea being that you have like a component attached to an entity that represents a resource rather than resources being their entirely own thing. My only issue with this is that resources are supposed to be singular, and they refer in here somewhere as like they say entity singleton entities, which to me makes me worry that somehow they're going to end up with a situation where you can have multiple copies of a resource, which is like very anti structure of what Bevy is intending to do. So as long as they keep it to a singular entity that spawns into the world that has all the resources attached to it, that really doesn't make any difference, because another issue is it'll fill the like editors and stuff up if they have an entity for every resource, and it also would, you know, again, defeat the whole like keep everything clean when you have dozens of entities that just hold a singular component that is their resource. Then they're adding the BSN file format and macro, which is about making a file format for Bevy scenes and will be an important part of getting the editor going. It seems interesting, but I haven't really looked into scenes since like version 0.9, so hopefully it goes cool. Next, they have light textures, which they call light cookies, but I've always known as gobos, which is the idea that you can apply like a shadowy effect to a light to make interesting things. So like dappled leaf effects or like like ones I've seen are like city skylines and stuff like that, where you can like project shadow that is the skyline of the city. Next is NVIDIA Deep Learning Super Sampling, which is a way of using a neural network to calculate anti-aliasing based on, I think you give it like frames and it anti-aliases them based on the previous frames. So you give it like 3 frames and it'll anti-aliasing on a time-based thing. It's cool, but it's not really that interesting in my opinion. The unified volumetric systems sounds interesting, which is that at the moment Bevy has God rays, fogs, and cascading shadows and atmospheric scattering, all these different ways of simulating like volumetric effects. And the idea is that they're going to try and unify this into like a one system, or like share more resources between them so they get a better interaction between all their volumetric effects. Then they're going to lay the foundations for ray tracing, which is that there's a lot of hardware acceleration out there for ray tracing at the moment, and they're going to sort of build on top of that to try and make it easier for Bevy to implement ray tracing in the future. And then more game-focused examples, which is kind of something that I've mentioned in a few of my videos when I'm trying to look things up, is that the examples are not very like, this is how you would actually use them. They're just examples of like, here's a very like bare minimum how you would get something to work. So they're planning on adding more examples that are in fact actually games. So that's kind of cool. So thanks for watching to the end of the video, and you know, check out the post. It'll be linked in the description. And I did have to cut a few things out because I was editing down a live stream and it just didn't fit, and there was nothing really interesting to say about them outside of they did a thing, or they like they're there. It's like, you know, improve this, and it's like, well, it's something to talk about because they don't explain really what they did to improve it. But yeah, it was fun streaming, and you know, hopefully this video that cut down like a 2-hour live stream into like I think it's like a 20-minute long video is interesting. So thanks for tuning in. Hopefully coming soon will be Bevy Basics Remastered, which is just like I'm going to go through and redo all my my Bevy videos, and like I'm just going to go through and redo all my Bevy Basics videos and like do like an updated one for 0.16, and that's a little bit more clear. Slightly more animated maybe, I'm not entirely sure. The first episode should be out soon, and it's going to be me making a like very basic game to sort of give people an impression of what it's like to make something in Bevy, showing off different aspects, so doing things maybe in like unconventional ways just to show off aspects of Bevy. So stay tuned for that. Don't forget to subscribe if you're interested in seeing that, and I'll see you in there.